Okay, so today's topic is geometry formulas. And here is some abbreviations. We're talking about values in geometry, which you probably have heard of many of them. So perimeter is P, area is A, the height is H, circumference is C, width W, length L, and sides of a polygon will be labeled A, B, C. It depends on the number of sides, then we go on to D, E, F, and so on. And the radius is denoted by R. We'll get deeper into those values soon. So the basic formulas for perimeters and areas of a triangle. So the perimeter of a triangle is A plus B plus C, the sum of the lengths, and the side lengths of the polygon. And the area of a triangle is 1/2 times B times H, where it's based on its respective height, and it doesn't matter which side length you use of the triangle as long as you use the height corresponding. Also, doesn't matter if it's a acute, obtuse, or right triangle as shown. So
these are some theorems we can use with are these some formulas we can use for triangles?
yeah. And there's also the Pythagorean theorem, which is specific to right triangles. It states that in a right triangle, in which A and B are the legs and C is the hypotenuse, A squared plus B squared is C squared. As you can see here. So basically the hypotenuse is long side of the triangle, and A and B are the legs, which make up the 90-degree angle. And I'm going to show you a proof of it.
You didn't share computer sound.
Okay. I'll then share my sound.
It's honestly such a lifesaver. If you don't know.
Hi, this is Presh Talwalkar. In this video, I'm going to show you one of my favorite proofs of the Pythagorean theorem. We'll start out with the right triangle that has legs of A and B and a hypotenuse C. The first step is to construct two identical squares that each have a side length of A plus B. Inside each of these squares, we're going to strategically place 4 copies of the original right triangle. What remains in each of the figures is green areas that are squares. For the square on the left, the lower left green area has an area of A squared, and the upper right square has an area of B squared. For the figure on the right, the green square has an area of C squared. Now comes the insight. We started out with 2 identical squares in which we placed 4 copies of the same triangle. So that means since the blue areas are equal and the original squares were equal, therefore the remaining green areas must be equal. And so what we have is a squared plus b squared on the left and c squared on the right. And therefore a squared plus b squared equals c squared. I hope you liked this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, on Twitter at Presh Talwalkar, or get my books at Amazon.
Okay, so I hope that you guys found this video cool and enjoyable. So there's another formula specific for the area of an equilateral triangle, which was this. So you could see this because it's from equilateral triangle with all side lengths of A. So we will then draw an altitude to one side. This divides one of those sides into two halves. So it's A over 2 and A over 2. Then to get the height, we can use the Pythagorean theorem, which we just learned. So that means that A over 2 squared plus h squared is equal to a squared. And solving is perfectly a squared over 4 plus h squared is a squared. Then h squared is 3a squared over 4. So h is a root 3 over 2. And applying the general formula for the area of a triangle, 1 over 2 times base times height, we get 1 over 2 times a, the space, times the height, a root 3 over 2, which equates to this expression. Now, using what we've learned, what is the area of a right triangle with its lengths measured 10 and 18 centimeters?
It is just 10 times 18 over 2. So it's 5 times 18, 90 centimeters squared.
Yeah, exactly. Since it's a right triangle, it takes one of those legs as the base and then the other leg will be a height. So it's 10 times 18 over 2. Now let's look at the next problem.
So can you give us a picture? Cause
Sure. I mean, it applies to any triangle, so you don't necessarily need a picture. I could give you an example picture, such as
if
then D will be here. So yeah, D will be on BC.
oh, okay, then the answer is, since they have the same height and ABD equals 18, it's 16 centimeters square. It's 16 centimeters square.
Right. You want to explain how you got it?
I can explain how I got it.
Sure.
So since the base is the same and the height is also the same, ABD is 1/2 of triangle ABC, which is 8. So ABD equals 8, which means ABC also equals 8. So 8 plus 8 equals 16 centimeters squared.
Exactly. Since they share the same height, and the base is an ABD is half. That's what we see.
I don't get the next. I don't get the next problem, cause
Yeah, this is pretty hard, so I'll just go over it.
you mean find the area of the triangle with side lengths 21, 28, and 35.
Yeah,
Well, for this one, 35 is the hypotenuse. So you just do 21 times 14, and you can split 21 into 20 and 1. You do 20 times 114, and then 14 times 20 equals 280. 280 plus 14 equals 294.
wow, that's great. Yeah, that's exactly how we should do it. First, we could realize that these are the lengths of a right triangle. And also, if you want to make it simpler to see, you can also realize they are all multiples of 7. And then scaling the triangle down into a 3, 4, 5 triangle, you realize that's a Pythagorean triple, meaning they're positive integers that make up a right triangle, since 3 squared plus 4 squared plus 5 squared. So then you could either use these numbers directly or first calculate the area of a 3, 4, 5 right triangle, which is just 6. And then find the area of the enlarged triangle, you'll times by 7 squared, since a triangle is 2-dimensional, so square 7. And that's also 294. Now we're gonna go over some quadrilaterals. For rectangles, the perimeter is 2 times the sum of the length and width, or 2 times length plus 2 times width. And the area is the length times the width. We could see all these simply. For example, the area to place squares inside the rectangle. And in parallelograms, the area is equal to the base times the height, where B is the base, such as here. And we could see this too by seeing you have a triangle here, you draw a triangle here, make a rectangle instead, move this triangle here. That's also base times height, as in a rectangle. And an interesting observation is that in the parallelogram ABCD, where T is any point in the exterior, we always have that TAB plus TCD equals TAB plus TBC, which is half of the parallelogram. Because let's take this TAB and TCD added, for example. Then let's call AB and CD as the bases, which must be the same length since they're parallelograms. And then this will be the height to AB and the height to CD. The sum of these areas is equal to 1/2 BHAB plus 1/2 BHCD, which by using the distributive property is this expression. And actually the sum of these heights is equal to the height of the whole parallelogram. So it can be written as this for the height of the parallelogram. And that's exactly 1/2 times the area of the parallelogram. And for a rhombus, which is a quadrilateral that has all side lengths equal, that's not necessarily a square since it can be compressed with different angles. Then the parameter is 4a, where a is the side length. And the area is the product of the diagonals d1 and d2 over 2. This makes sense because we could draw a rectangle outside of the rhombus, and then the rectangle will have a length and width of d1 and d2. So you can actually see the rhombus is half the area of the rectangle, because for every of these little rectangles, these triangles are equal in area.
Can I go to the restroom?
Sure. So for now, trapezoid.
Can I
I think
have a parallelogram?
I think I also learned this.
yeah.
Wait, the trapezoid is like AB over 2 times H. Yeah, A plus B.
Can you do a B? Can you instead do like B1 plus B2 times H divided by 2, or do you have to do B1 plus B2 divided by 2 times H?
Either way is okay. You could also do the other way, and they're equal to the same value since they're about the commutative property of multiplication. So it doesn't matter which way you calculate.
Are you going to do some example problems?
Like
Yeah,
when
later.
when I learned it, for the trapezoid area formula, it wasn't like top base plus bottom base times the height divided by 2.
Wait, I have a question.
Yeah.
For this trapezoid, is it like an isosceles trapezoid?
Not necessarily. I think the diagram looks like that. It doesn't have to.
You can double it and then put another flipped trapezoid on the other side, and then you divide by 2 of the area of the parallel.
Yeah, exactly. That's a smart way to prove it. So yeah, that's basically the area of a trapezoid.
So is the area of the trapezoid like the top base plus the bottom base times the height divided by 2?
Yeah. So now for circles, the radius, which is the distance from the center to any point on the circle, is r, and the diameter is d, where that's the length from 2 points on the circle that passes, in which the line segment connecting them passes through the center. And the diameter is 2r, which you can see it's basically extending to 2 points on the circle from the center, and since it's a straight line, you add them up. And the area of a circle is r squared times pi, and the circumference, which is a word that means the perimeter of a circle is pi times d, or 2 pi r.
In this case, if we're going to do problems about the circle, do we just leave the pi out or do we round it?
Well, I haven't saw. I think we could do either when we submit the questions.
Okay.
I have what is that? I still don't know that little line. Like for example, the area of a circle is radius what is that one next to the r squared? There's
Next
a
to
little there's
pi?
a sign. There's a sign next to the radius squared in the area of circle. What's the sign? What is it?
That's pi, which is about 3.14, and it's also about 3.1/7. So this is what mathematicians would calculate to be the area and circumference. Use pi to denote the number. We don't need to get into why. It's just, I guess, mathematicians early on, like
Does that matter?
does,
Does the sign matter?
well, we just use that to denote the value of pi, because that's the exact value for the area of a circle. Or you could approximate to like 3.14. Sometimes
Okay.
in calculations.
Okay.
Yeah, given a sector of a circle in which L is the length of the arc, A is the area of the sector, and theta is the angle of the sector, we have that L is equal to 2 pi r times theta over 360, which can be simplified to pi times r times theta over 180. And the area for the sector is r squared times pi times theta over 360. You could see these simply because they take basically the area with the circumference and then times by the ratio of sector to the whole circle. Since
Yeah.
the whole circle, yeah.
My question is, in this case, what does theta stand for?
Theta. Okay. So theta is like a variable to denote any value, just like x. But theta is usually used for angles, whereas x and other lecture variables are used commonly for numbers. But later in math and math competitions, you will commonly see theta used for angles.
Okay, so it's like a variable.
Yeah.
So if in this case, how will we solve the L thing if we don't know what the variables is?
Well, if you don't know what the variable is, well, I mean, for the sector, you only would solve it if you know the angle of the variable. For example, if it's 60 degrees, then you plug it in. But if you don't know what theta is, then you could only write them in this expression with theta denoting the unknown value. So these equations are only used when you know what theta is for now.
So we don't use those like formulas?
Or, well, what? Sorry.
Wait, so we don't use the formulas if we don't know what data is?
Yeah. Then usually you won't be asked to calculate the area or the length unless if you know data.
Okay.
So now we're going to take a look at some problems using what we've reviewed. So take a look at the first problem. And we're not going to have Kahoot, so we could chat it once you get the answer or shout it out.
Can we shout it out?
Sure. Although, yeah, you could go.
So for the first question, it is 8 units.
Yeah. It seems some of you already got the answer, so good job. It's simply to just plug in a formula for the triangle, but this time the unknown is height. And then solving for h is 8. Just when we're doing these kinds of problems, be careful that for triangles you have to multiply by 1/2, or else you'll get 4. Now, in the rectangle shown, ratio of width to length is 1/4. What percent is shaded? Yeah, it looks like one of you chatted me the answer. So it's 50%. There's 2 ways to do this, at least. One is to try to set ratios like x and 4x here, and then calculate the ratio and calculate the area of the triangle. But actually, you could realize that this information about the ratio of the lengths are unnecessary. So you could just see that use the triangle here, and there's the base and the height of the triangle and rectangle are same. That means that ratio of the areas be base times height over 2 over base times height, which is simply 1/2.
In this case, the 1:4 ratio is not needed.
Yeah. So we're going to take a look at next problem. So first, we're actually almost done with this week's lecture.
I have a question.
Okay.
Wait, are you on the points A, B, C, and D one?
Yeah,
Is the larger square? Is it the larger square? Is the A, D, C, B, or the which one is the larger square?
larger squares.
Then,
It's
and
not
which one
ABCD.
is the smaller square?
That's ABCD.
Oh, then the answer is 30.
Exactly. You want to explain how you got it?
I just did 60 divided by 2 because each of the small, I don't know how you explain it, because each of the smallest triangles, they add up to be A, D, C, B. So then you just do 60 divided by 2.
So that's exact sense. You could think of this smaller square like rhombus. Then it's basically showing how the area formula works for it, like I did. These triangles and these triangles are equal area. So it's 60 with 2. So before we discuss the next problem, how are you going along with today's class? Do you think it's easy, hard, medium, and slow or fast?
I think it's fine.
Good to hear. Yeah, we'll still have quite some time left, so we could spend some time going over homework.
There are 3 problems I want your question on for homework.
Sure. We could go over that right after we finish 2 problems. So for this problem, tell me your answer.
Wait, can you make it a bit larger? Can you move to the second problem?
Sure.
Is the first problem 36 pi?
Well, it's actually something close because 36 pi is the area of the whole circle, so that's 6 square pi. And then to find
It just
you say 60?
I use 60 as theta.
Yeah.
But pi r Wait. So I'm supposed to find the area of 120, the 120 part, and then do the whole area minus that.
We're actually finding the area of the shaded part, so that's 2 times the area of the sector 160.
Wait, so what is it going to be then?
Okay, so it's 2 times 36 pi, the area of the whole thing, times 60 over 360, which simplifies to 12 times. Now, here's a final problem in our geometry class units today.
What about the second problem?
The second problem.
Yeah.
In
Arc.
sorry,
I have an idea for how to solve the arc. Can you make it a bit larger?
sure.
Okay. So wait, is B and E centers?
B is the center of quarter circle AG, but E isn't a center.
Okay.
Or
So
actually, sorry, it actually is for CF.
I kind of feel like the answer is 8.
so what you do?
That's correct.
So what you do is like you see what ABG is a quarter circle, and FEC is another quarter circle, and then all you have to do is find the whole area of the rectangle, then minus the part of the tiny part. What is that thing called? Triangle. Yeah. So
You
you
could
do that, and
just
then
call it part.
you find the area of ABG, then you do a whole rectangle minus ABG and minus that curvy thing.
Yeah, that's right. So actually that would equal the area of one of these long rectangles, because on the whole rectangle is 3 of these long rectangles, and this plus this is 2 of these rectangles. Since,
So like you sort of move the pieces around.
yeah, exactly.
Yeah, I like the first thing I did was to move the first 2 triangles, the first 2 rectangles and the shaded part to like moved it so then it's equal to one rectangle. So then I just did 4 times 2.
Yeah, exactly. Good job in this problem. You guys impressed me. Yeah, and wait, there's many ways to prove that it's 4 times 2. Another way to move them is moving this here, moving this part here, which also makes the area 4 times 2. Okay. Now, since we have covered all 4 geometry formulas, we're gonna look at last week's homework.
So the 3 questions I have is, let me find where it is. So the 3 questions I have is 3, 5, and 6.
Okay. For 3, can you explain to me what you thought of first?
So I tried visualizing what it looked like. And each time they could be switched once. If you add 1 try, then they can switch once, and then you can keep doing it. But like there's a lot of combinations for the number of wire pairs you can have for 7 wires.
Yeah. So this is also pretty challenging. You could think of it. The answer is actually 7 choose 2, because you could think of it, there's 7 wires, and each test it has 2 wires. So how many ways are there to choose 2 wires from 7? And if you remember the formula for this and plug it in, that's 21.
Okay.
Yep. And so the next is 5. Well, did you get 4?
I think 4 is 60.
I think you're right, because that's, they would do 9 choose 3 actually. Yeah, so it's then 9 choose 3. Well, I think 9 choose 3 is 84. So that's for 4. And then, but for 5, you use a similar approach. So then this time, there's 10 numbers you could choose from, since the ones that it can be 0. So it's 10 choose 3.
So the 2 and the 8 cancel, and the 3
Yeah.
and 9 cancel.
120.
Okay.
Yeah. Okay, now 6. How many ways are there to get from A to B if we can only go north or west? This problem is similar to the water pipes problem we saw last week here, except this time, instead of going only east and south, you will go west and north. And if you look at the picture, to go from A to B, we'll have to go through C. So you can divide into 2 steps, going from A to C and going from C to B. Then, to go from A to C, you could see there are 4 steps you have to take to the left and 2 steps you'll have to take upward. So that's basically rearranging 6 terms in all. And to arrange these, it's 6 choose 4 or 6 choose 2. Because you choose where to put one type of the arrows. And can someone tell me what that is?
You can cancel 2 with 6, you get 3. So the answer is 15.
Correct. And now for case 2, can you try it yourselves and tell me your answer or how you got it?
What do you mean by case 2?
Like go from C to B.
Wait, I have a question.
Yeah,
How did you get 4 for the Tuesday?
4. For which step?
The 6 choose 4. How did you get 4?
Oh, because there's 4 left arrows. You have to go, or you do 6 choose 2. So either way, for instance, left arrows, you choose how many ways are there to place left arrows in 6 spaces. Since in all 4 left and 2 up will take 6 spaces. And that's the order if you read them off. How you go from A to C. For example, do this. Then next you go left, up, left, 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 up.
This is a permutation problem, right?
Right. So it's actually a combination problem through the casework, but then to take care of those both cases, it can be considered permutation.
Okay, I see. Ten.
That's correct. How do you get it?
So this is a combination problem. So, you do 5 factorial over 3 factorial times 2 factorial. You cancel the 3 factorial, you have 5 times 4 over 2 equals 10. Because you cancel the 4 and the 2, you have 5 times 2 equals 10.
Exactly. So it's either 5 choose 3 or 5 choose 2. Also write it as this simpler. So there's actually no Kahoot this week because I thought most of the problems they involve some pictures which are hard to put, and also that I felt there was still enough content this week, so we won't go overtime. Okay, do any of you, first, so to finish up problem 6, you
Sure.
could, do you want to explain how to finish up problem 6?
Wait, you mean me?
If you want.
Well, there's 15 and 10. So I think you can maybe add them together.
It's similar. Like
Wait.
grouping, we usually do multiply or divide for grouping. So it's
You mean that choose thing?
well, for this part, since we already know, we use choose to calculate each of these cases, but to calculate the whole thing, we actually multiply them together because you would think those are independent. So to construct a tree diagram kind of for each possible value of A to C, you'll have 10 for C to B because they're independent. So it's 15 times 10. Is that clear?
Yes.
Right.
Thank you.
No problem. Do any of you have more questions? If not, I'll go on to question 7. So for here, it's actually supposed to be a square. Yes. And any of you, if you think it seems
Like, I have a question, like, for the rectangles, they're like those little squares. Do the squares count as rectangles?
the squares, they do count as rectangles. Yeah.
Oh.
Is the answer 54? Or is it more?
I think, hold on. I'm also thinking. Yeah, it's a bit different, but it's close.
Well, maybe I missed 4 of them. Wait. Let me try solving it again. Wait, so what is the answer?
The answer, I'll give it to you now. 60. So what we do is we could consider
6 squares. Yes, you probably missed 6 squares.
so maybe another way, although casework is a way, another way to do it is to consider permutation combination counting. We could consider 2 dimensions. First is this dimension, and another is these dimensions. For one of these dimensions, for each of them, you'll have to choose 2 of these straight parallel lines or borders of rectangle, and the other dimensions do the same thing. That'll also always form a rectangle. That's exactly the number of rectangles if combine them by multiplication. So for one dimension, there's 5 lines. You have to choose 2 out of those 5. And for the other dimension, you have 4 lines. So you choose 2 out of those 4 lines. And since those dimensions are independent, you can multiply them up with no more adjustments. And then that's 10 times 6, or 60.
Okay. Well, thank you for telling me how to do the homework problems.
No problem. I hope that you found them interesting and cool.
Oh, yep. Thank you for teaching me. Bye.
Bye.
Thank you. Bye.
You're welcome.
Bye.
Thank you. You're welcome.